This incident serves as a stark reminder of the extreme risks associated with high-voltage maintenance and the critical necessity of rigorous safety protocols. The root cause is a phase-to-phase short circuit where non-insulated tools bridge voltage potentials, forming an arc plasma channel with extreme temperatures. Clearance violations and the absence of lockout-tagout LOTO protocols remove the essential zero-energy state buffer, leaving no margin for human error. Systemically, the normalization of deviance leads to hazard recognition failures, while outdated exposed equipment lacks physical insulating barriers. To mitigate these risks, organizations must mandate LOTO procedures and install non-conductive barriers. Administratively, personnel must utilize specialized arc-rated TP, adhere to approved standard operating procedures, and always assume equipment is energized until verified otherwise by calibrated tools. Adopting a proactive, task-based risk assessment is essential for maintaining safety. The video captures a textbook example of critical visibility issues and blind spots in urban traffic. The motorcycle operator entered a no zone in front of a truck, where the elevated cabin makes it nearly impossible for drivers to detect smaller vehicles. The incident was primarily caused by the motorcycle pulling from the curb and crossing in front of the truck without ensuring a safe gap or signaling. This highlights the vital need for defensive driving. To stay safe, road users must follow the golden rule. Never linger near large vehicles. If you cannot see the driver's side mirrors, they cannot see you. Always prioritize yielding to heavy trucks, as their ability to maneuver is restricted. Maintaining a constant 360-degree scan at intersections and asking yourself about an escape route if a driver fails to notice you are essential habits. Ultimately, your safety depends on your own proactive choices, not just the attentiveness of others. This incident highlights severe risks in heavy machinery operations, underscoring the importance of systemic maintenance and preventive engineering. The primary failure involves the hydraulic lifting assembly, where cylinder fractures, hose bursts, or check valve malfunctions cause immediate pressure loss. Simultaneously, structural fatigue from corrosion and cyclic loading, exacerbated by overloading, compromises critical pivot points and welds. Systemically, the lack of secondary safety measures turns the dump bed into an uncontrollable hazard during primary system failure. Gaps in preventive maintenance schedules often leave these structural defects undetected. To mitigate these risks, organizations must implement a dual-layer strategy. Engineering controls like pilot-operated check valves and mechanical safety locks, combined with administrative rigor through pre-operation checklists and hazard awareness training. Ultimately, operators must adopt a never-trust material stability mindset, performing task-based risk assessments to ensure safety protocols are active before every operation. This incident highlights critical systemic failures in manual material handling, where shifting centers of gravity in heavy containers often exceed human control. When operators attempt to manage such mass without mechanical support, the risk of an uncontrolled gravitational torque becomes inevitable. Compounding this, surface hazards like oil spills reduce floor friction to near zero, eliminating an operator's ability to maintain traction. This scenario illustrates the normalization of deviance, where past successes lead to bypassed safety protocols until a minor instability triggers a domino effect of accidents. To prevent such events, workplaces must prioritize engineering controls, such as automated pumps or fixed-axis dispensers, over manual techniques. Furthermore, installing anti-slip flooring and containment trays is essential. Ultimately, safety relies on robust system design, not individual dexterity, requiring training that emphasizes disengaging from unstable loads rather than manual intervention.